All right, these notes are on using systems to solve word problems. And after you have solved systems with one, you guys may not have realized this, but you've already done this with one variable. It is such a pain, and it is like heaven when you get to be more advanced like you are now, and you get to use systems to solve word problems, because then you get two variables and you get to use two equations and two variables, and life is so much better. So the first one is interpreting a graph. Okay, and you're going to get a lot of these. And it's basically going to compare a couple of things and ask you, most of the time, it's going to be asking you to find or to recognize this point. This point is the point of intersection, okay? That is the point where something happens. In this case, it's where plan B becomes less expensive than plan A, and it's where plan A gets more expensive. And that's what you're supposed to recognize. Right here is where they are exactly the same. Okay. So it says Keiko can choose plan A or B for her long distance charges. For each plan, cost in dollars depends on the minutes used per month as shown. Okay. So just taking a look at these graphs real quick, notice this one is just starts at zero. Like you have no upfront costs. You just get charged per minute. This one, you pay $6 upfront, and then you pay per minute. Okay, it says if Keiko makes 200 minutes of long distance calls for the month, which plan costs more? So really, they're just asking you to reference the graph. 200 minutes is right here. And then you're supposed to just look. Plan A costs more. How much more does it cost? Okay, so the idea is that you are looking to compare the Y value. Obviously, the X value is the same. So here, the Y value is 14. And here, the Y value is $2 more, 16. So 16 minus 14 is $2 more. For what number of long distance minutes do the two plans cost the same? Okay, and that's where you're supposed to recognize that they're the same right here. And that would be 150. If the time spent on long distance calls is more than this amount, which plan costs less? Now, this is a lot of language. Okay, so let's start. If the time spent on long distance calls is more than this amount, what amount? That amount. Okay, they're referring to the previous question. Which plan costs less? Well, once you pass there, plan B is less. So it's plan B. And that those are just interpreting graphs. Okay, next question. Solving a word problem involving a sum and another basic relationship. Okay, that's just a really wordy title. It's basically involving the sum of numbers. So what you're going to do for these is you are going to use two variables, and it's lovely, because look, you get to write x plus y equals 54. Check it out. You get to write two variables, and you'll see why it's wonderful. So the sum, you do need to know these words, you guys. Sum is plus. Difference is subtraction. Product is multiplication. And quotient. Quotient is division. I guess I could put like that, the symbols there. Division. Okay, so let's start out with and just translate this. It says the sum of two numbers is 54. The sum of two numbers is always as equals 54. So we are going to go ahead and say we got x and y. You can decide which one is going to be the smallest number. It doesn't matter. I'm going to say x is smaller, y is larger. Okay? The smaller number, what's that one? X is equals 10 less than. 10 less than. Remember, I did a big old lecture about that less than, okay? Means you have to take it from something, the larger number. There. What are the numbers? Look, you guys, you have two equations and you have two variables. And now check this out. Look how easy this is to use substitution. X is equal to y minus 10. Well, here's X. All you do is plug it in, okay? Plug it in, substitute it in. Y minus 10, which is X, plus Y equals 54. Get it? All we did was plug in the value of X. This is substitution. So we get 2y minus 10 equals 54. Add 10, 2y equals 64. Y equals 32. Okay, so that's what it says the larger number is. Okay, so we could say the larger is 32. The smaller is going to be 22. Why? Because look, it says the smaller number is 10 less than. Okay, here's the thing. Now let's check it. Do they add up to 54? And yes, they do. Therefore, it checks. Okay, you're going to get a lot that are very similar to this. I didn't give you a second problem like that. I guess I didn't. Okay. All right, that's okay. Here we go. All right, solving a value mixture problem using a system of linear equations. Okay. So these are typically, again, setting up two lines and you get a system, two variables, which is really nice. So the Patterson family and the Robinson family each used their sprinklers last summer. The water output rate for the Patterson's family sprinkler was 30 liters per hour. So I'm just going to write this down right now because it's a lot to take in. 30 liters per hour. Okay. The water output of the Robinson family was 40. So I'm going to put Robinson. And honest, this is a strategy of just writing down what you know while you're doing a problem, writing what you're finding out to organize the information. Okay, I actually have no idea what this problem is about yet. Okay, the families used their sprinklers for a combined total of 55 hours. Okay, so I can write hours of Robinson plus hours of Patterson equals 55. Just, I'm organizing my thoughts, right? This is all we did. Okay, all I'm doing right now. Resulting in a total water output of 2,050 liters. Okay, so water from Robinson plus water from Patterson is equal to 2050. All right, so far we don't have anything we can work because we just got words. We're going to try to convert these, okay? You can use the outground, whatever. Okay, how long was each sprinkler used? Okay, so we're talking about hours. This is time, and we're talking about hours. Okay, so, sorry. Okay, so what we're going to do is, do you see how we need hours of R and hours P? I'm going to say, because we need hours, okay? Whatever your question is, that's your variable. I'm going to say let R equal the number of hours that Robinson used. Okay? Let P equal the number of hours Patterson used. Okay? So now we know we can change this. I can actually just erase the words hours. And I will get R plus P equals 55. I'll make it look nicer though, okay? R plus P equals 55. Okay. Well, how do we get the water from the Robinsons and the water from the Pattersons? Okay, Robinsons was 30 liters per hour. That means like for 1 hour, just thinking about this is not the answer. It would be like, okay, every hour, it'd be like 30, 60, 90. It's going to go up by 30. And the other one is going to go 40, 80, 120, ... Okay. So the idea is that for every hour, we're going to go up a certain amount. So it's a multiplication. Okay. So we're going to go, erase this. The Robinsons used 40. So we're going to go 40R plus the Pattersons used 30. 30P equals 250. And these are our two equations. Look, two equations, two unknowns, and now we can solve. So you have a choice. You can use elimination or you can use substitution. I prefer substitution when it's this simple. So I'm gonna use equation, I'm gonna number these, equation 1 and equation 2. I am going to solve equation 1 for P. It doesn't matter what I choose, I just like P better. So R plus P equals 55, which means P is equal to 55 minus R. Agreed? So then I'm going to take this and I'm going to plug it into P in the second, just so you know that's multiplication, in the second equation. So now I'm going to go plug it into 2. So it's going to go 40R plus 30 times 55 minus R equals 2050. And look, now we have one variable. 40R plus distribute 30 times 55. I don't know what that is. Go ahead and use your calculator. 1650. 1650 minus 30R equals 2050. Okay, subtract 1650 from 2050. We're going to get 0. I hope I don't screw up. 0. And then 400. Yeah, okay. And then 40R minus 30R is 10R. And then divide, and you're going to get R equals 40 hours. Okay, that's what we were looking for. Remember, R is the number of hours of Robinson. So the Robinsons used theirs for 40 hours, which means if the total hour is 55, right? You can plug it back into here. And then you'd realize that P was 15 hours. And then you could check it by plugging it into the second equation. Okay, you'd go 40 times 40, which is 1600, plus 30 times 15. 3 times 15 is 450. And is that equal to 2050? Indeed it is. So it checks. You can always plug it into the second equation. All right. So I don't have a title on this one. Again, it's just a word problem. Okay. It's about pulling the information from a table and writing an equation. A party rental company has chairs and tables to rent. There were 2 customers who rented both chairs and tables last week. The table below shows the number of chairs, the number of tables, and the total cost for those 2 customers. Okay, so here's your first customer and second customer. Okay, I think it's hilarious that they only rented 5 chairs and 3 tables, but they must have had a lot of chairs sitting around. That's all I'm going to say. Okay, were people just standing on the tables? Maybe they were just putting stuff on the tables. Who knows? All right, let X, they're even telling you what the variable is. You guys, let X be the cost to rent a chair. Let Y be the cost to rent a table. Okay, write a system of equations, okay, that could be used to find the rental cost of each chair and each table. So if X is the cost to rent a chair, it's going to be 5 times X plus number of tables, 3 times Y equals 37. Basically, you're just multiplying it by that variable. The second equation is 2X plus 6Y equals 64. Then it says how much does each chair in each table cost? They just want you to solve this system. Okay, this kind of system is much easier to solve using elimination. If you recognize the first equation has a 3y and the second equation has a 6y. So what I'm going to do, first of all, I'm going to number them so that you know which equation I'm talking about. But what I'm going to do is I'm going to multiply equation 1 by -2. And the reason why is because that way I can get this to be the opposite of the this bottom one, 6y. I can get these to be opposites and I can cancel them out. So here's the reason why. Here's my new number 1. It's going to be -10x minus 6y. This is a cool little trick that we have learned how to do. It was absolutely my favorite way of solving. 74. And then 2x plus 6y, this is our 2, we're not changing it, equals 64. And then we cancel, and you get 8x equals 10. -10. Well, x can't be negative. Oh, that's -8x. That makes sense. Okay, so x is equal to 10 divided by 8, or 5 divided by 4, or $1.25. Okay, 5 quarters is $1.25. Okay, so cost to rent each chair, $1.25. Okay, how much does it cost to rent a table? Plug it back in. It doesn't matter which equation you plug it back into. I'm going to plug it into 1. Okay, so I'm going to go 5 times 125 plus 3y. Whoa, I can't do that. That doesn't fit. Here, get over here. Eraser. Here, I'm going to change colors and I'm going to plug it in and I'm going to plug it in over here. Okay, so I'm going to plug it into number 1. Okay, 5x plus 3y equals 37. 5 times 125 plus 3y equals 37. I plugged it in. Then 5 times 125, that's $1 plus $1.25 is, $5 plus $1.25, $6.25. 6.25 plus 3y equals 37. And then you need to subtract the 6.25, and you're going to get 3y equals 37 minus 6.25 is going to be 31.75. Is that right? 31.75. Let me think. 25 is carry. No, it's 30.75. Yes, that's right. 30.75. Divide by 3, and you're going to get y. Wow, I'm so sorry. We're all over the place. Y equals 10.25. 3 goes into 75 25 times. Okay, 3 quarters equals 75 cents, so 10.25. And those are your answers. You could plug them back into each equation to see if you are correct. Solving a value mixture. Okay, value mixtures are really interesting. They're sort of just, again, organization. That's probably the best thing you can do, is just start writing down information and then organize it. The Reed family and the Wood family each used their sprinklers last summer. The water output for Reed is similar to the one we did, 30 liters per hour. The water output for the Wood was 20. Okay, they used a combined total of 45, resulting in a total water output. This is exactly the same. I wonder if I think I must have meant, maybe I didn't mean to put it next to it. I was thinking, I think I just got a second problem so you could try it. As always, you guys, highly recommend you shut off the video and try the problem on your own and then check your work. Okay, so I'm going to put R equals, Well, R equals number of hours. Reed's family sprinklers were turned on. W equals the number of hours. Wood family. So R plus W equals 45. And then for every hour, the Reed's was 30R plus 20W for the Wood family equals 1200. And now we have our two equations. Okay, I'm going to solve this one for R. R is equal to 45 minus W. I'm going to take that R and I'm going to go plug it into here. So 30 times 45 minus W plus, don't forget to bring that down, 20W equals 1200. Part of the reason why you try to keep your organization vertically down is to not lose things along the way. 30 times 45, 5 is 90, 90 is 135, so I think it's 1350. Right? 3 times 45 is 15, 135, yeah. Okay, minus 30W plus 20W equals 1200. Subtract 1350. I'm just going to do it in my head. I'm going to get negative 150, and I'm going to get negative 10W. So W is equal to, divided by negative 10 on both sides, 15. Which means if W is 15, plug it back in, and you will get R is equal to 30. All right, and then you would go away. Okay, and then you would write that appropriately. Next problem. Okay, no, I don't need this. I'm sorry. I'm over this. We did this already. Delete, delete, delete. I guess that's it. Delete, get over here. Okay, you don't need to see me delete this. This is not important. Okay, that's it for these notes then.